person has a rectangular garden that has a length of 15 feet longer than the width. Set up a quadratic equation to find the dimensions of the garden if its area is 100 square feet. Solve the quadratic equation to find the length and width. So, in order to get things organized from a problem that is applications based or a word problem that is, a great starting point is always drawing a picture, because too often students want to just scan through and look for numbers and then be like, here are numbers. I'm going to say it's 15 times 100, done, move on. Well, you don't understand the problem, you don't know what you're looking for, and you don't know how to solve it. So to figure that out, you have to take a moment to try and digest the information and make sense of it. So let's see what we have. First off, we have a person with a rectangular garden. Okay, well, that's something we can work with. I know what a rectangle is. Here's a rectangle. So here's my garden. Okay, now it has a length of 15 feet longer than the width. So I have two dimensions to my garden. I have length and I have width. So I'll just define those. Now, if that's my length and that's my width, the one thing that I know about this is whatever the width is, the length is, so the length equals, you can always replace is with equals, 15 feet longer than the width. So I've just taken this piece of information and written a formula from it. So the thing about scanning for numbers, it doesn't usually work because you're not always scanning for numbers, you're scanning for formulas. So we have, this is a length of, or is, 15 feet longer than the width. There's a formula that you can work with, and it's just sitting right there. You just have to translate the words into math. Set up a quadratic equation to find the dimensions of the garden if its area is 100 square feet. All right, well, that's another piece of information that helps. So we have the area of this garden is equal to 100 square feet. Solve the quadratic equation to find the length and the width. Okay, well, another thing we know about area just from geometry is for a rectangle, it's length times width. And I actually know what the length is. The length in terms of the width is 15 plus W, and then times another length of the width, sorry about that, distance of the width, I should say, maybe. So I can say the length times the width is equal to 100, so that's just the definition of area. And this is the quadratic equation they're talking about, because if you'll notice, if I distribute this W, I would have 15W plus W squared. And it's quadratic because I now have a squared term, which means if I bring everything to one side, 0 equals W squared plus 15W minus 100, I can try my different methods of solving quadratics. One is factoring. So let's see if it will factor. So two things that multiply to W squared would be W times W. Then 5 times 20 would multiply to 100. If the 20 is positive and the 5 is negative, they would multiply to negative 100, but then also add to 15. So that means W minus 5 could be 0, and W minus 20, or W plus 20 could be 0. So W equals 5, or W equals negative 20. Now, consider that these are physical dimensions. So we're saying that the width should be 5 feet, or the width could be negative 20 feet. Because it's a physical dimension, I think we could rationally throw out that negative, because the width would have to be greater than 0. Now, the next thing is that tells me the width is 5. So if the width is 5 feet, then we can find the length because the width is 15 plus w. So 15 plus 5 gives me 20 feet. And that's the length. And just as a check, I now have a garden whose area is 100 feet square, and certainly the length is 15 feet more than the width.